US might be over here in another place. And what normal distribution does is to give you a sense of the range, okay? The range. We do that with GPA. We do that with a lot of things, salary and all that. So the distribution, and so if you look at what it says here, the normal curve, I think page 6. I want to correct myself. You can find the median, mode, and mean here, and this is the page. So they are, you can find out what they are right there on the normal distribution. So look at page 6, okay? If you look at the curve, the middle means whoever is right in the middle, right? So the median is the tip of that, okay? There are 50% of people who are more and 50% of people who are less. So if the person is right in the middle, like for height, right? So the median height in US, so this curve will be very different in different places, right? Think about it. This curve will be very different in different countries because who is right in the middle is really different. Okay. Mode is the most. Let me see if I can. Yeah, this is actually, how many of you have seen this a lot or have actually done anything with this? Yeah, you might not need to calculate anything, but you need to conceptually understand it. Conceptually. So let me try again. Let me draw something really much better than what I'm drawing. And actually, if you look at the, I'm going to draw what is in here. Page 6. Okay. Sorry. That's okay. Probability, page 6. Yeah, page. I know it already. Yeah. So if you look at what it says there, I want you to tell me whether it makes sense to you. It says there is a point that is the mode. And then there's a point that is the middle. And then there's a point that is the mean. So tell me, why, is there a time when those three things are all the same? Could it be possible?
No. Yeah. Okay.
Think about it.
You got me thinking.
Think about it. So,
Well, yeah, they could.
because if everything is spread out perfectly, right? That everything is like perfectly centered. Then the middle number and the most number and the average is all the same. It's rare, okay? So if you look at the top of that would be the only time it is exactly the same if it is exactly, okay? Like exactly even. That if I were to fold this, it would be exactly the same. That means there are exactly this many people who are on one side, as many who are taller, right? Let's say this is height. That means you have exactly the same number of people on one side versus the other side. Or weight, same thing. You have exactly the spread of people who are less than a certain number versus the ones that are more. In real life, that doesn't happen very often. Okay? It doesn't happen very often. Right? But it's possible that this could be the mode, which is the most. Right? Mode is the most. It could also happen to be right in the middle. Right? And I think it means that when it's in the middle, you are right in half. Half of the people are before you and half the people are after you. Okay? Exactly in the middle. Okay? And if you add everything up and divide it up, that middle is also the mean, right? That means you are averaging everything out. Very rare, very rare. That doesn't happen very much. Okay? all you need to know here is about the whole idea of standard deviation. Okay? So this actually is a very nicely explained thing. Again, you don't need to learn how to calculate it, but understand the concept of standard deviation. The idea is that how far are you from the mean? Okay? The farther you are, the less you are. Like for me, I'm very like second standard deviation from the mean of height probably, right? I'm so far away. I'm so far away because the people here on average are way taller than I am. Okay, way taller than I am. So the understanding of standard deviation, if you understand in concept, that's probably good enough. I don't think they will actually ask you how to calculate that. But understand that in mode distribution, there is a spread, that there's always a lot of people sort of in the middle, and then some people at the end, the outliers, right? On one end or the other. Same thing with GPA, right? You have people mostly maybe in the B's, and then you have people who are really low and they are failing. And then there are people who are like, wow, 4.0 plus, right? They are like off the chart, right? So the idea of a distribution means that you will always have folks kind of in the middle, some who are very low and some who are very high. And it's always spread out about the same. It's a matter of whether it's spread out nicely or spread out kind of weird.
So
Okay.
what would be the questions that we could find?
I think it has some questions here. So look at page 8. Yeah, I think, I don't know whether the person who put this together, I don't see problem that she put on here for that question, which I'm surprised. This is like, showing you how to do that, but then we don't have problem with that. Let me think about that. But could somebody read page 8? Or maybe take turn to read it. Page 8. It's about schools.
If you are comparing test scores for different schools, the standard deviation will tell you how diverse the test scores for each school. Keep going.
Sure, if you, okay.
Let's say Twin Cities Elementary has a higher mean test score than Northrop Elementary. Your first reaction might be to say that the kids at Twin Cities are smarter.
Keep going.
I can,
Oh, go ahead.
No,
You don't wanna keep
No, I just thought anybody was gonna.
If somebody else want to read it.
But a bigger standard deviation for one school tells you that there are relatively more kids at that school scoring toward one extreme or the other. By asking a few follow-up questions, you might find that, say, Twin Cities mean was skewed up because the school district sends all the gifted education kids to Twin Cities, or that Northrop scores are dragged down because students who are relatively or recently have been mainstreamed from special education classes have all been sent to Northrop.
We could almost draw this, right? Would that help to visualize it? Because that's the kind of question they will ask you. They might give you two graphs, right? They may give you a number of the mean score, and then they will ask the question, does this mean that this school, all the kids are smarter? Right? Can you actually say that? You will say, no, it just means that there are a lot of students who are smart, but then there's also some students that are not doing very well, right? So you can't just take one number and just kind of say, yeah, on average, everybody's doing well. But so the idea is that let me see if I can draw the situation here. So Twin City has a higher mean test score than Northrop. Okay, the bigger deviation for one school tells you, for example, Twin City means was skewed. So if your scores look like this versus another school that look, let's see if I can do this here.
all right, that's the standard deviation variation, right?
Yeah, right? So let's say the score is here. So the higher the score is going this way, right? So the score is, the more you go this way, the higher it is. So you might say that, oh, this school is score, you know, the median score, maybe the mean score will be, the mean score might feel like it's lower. It could be, because there are less people who, this is higher. But you could say, well, but there's a whole concentration of students who are not that low. Or actually are high, not low, high. Okay? So knowing this, that one number, let's see, that one number right here, doesn't tell you everything. It tells you the spread. It tells you the spread. Okay?
So to me, it sounds like it's eliminate any extreme.
Well, or if you know if they're extremes, right? By having the graph, by understanding the standard deviation. If you have a lot of students in the second standard deviation, means that your spread is really big. If your student score is closer to one standard deviation, or that one standard deviation is close and not that far away, then most people are kind of about the same range. So standard deviation tells you how large the spread is. So again, they will not ask you to calculate, but they may ask you, say, like, which one have a bigger spread? Okay, so standard deviation might be about spread.
Then the lower one.
Has more spread.
Spread out.
Yes,
Okay,
on the upper end,
I
right?
got you.
The scores are more spread out on the upper end.
So you just have to read a picture.
Yes, you may learn how to read a picture, understanding what standard deviation means. So you're gonna need to study this, and this actually did a good job explaining it. Okay, so keep looking at this example, right? The idea is that one number alone doesn't tell you the whole story. The spread might tell you more about the school, right? And that's the reason sometimes when you see like, what do you call it, like a newspaper, and they want to say this school is not doing well, but when you actually look at the whole spread of the scores, it might give you a different picture.
Do you think they're gonna give us picture with the
It might, yeah.
words, or we have to come up with a picture?
I have no idea.
Because when I have to come up with a picture, it's harder.
It's a little harder.
It's my second language. I have to figure it out.
Yes, and so understanding, so if you look at, so that's what I don't have it in this packet that I realized. So let me make a note of that. I'm going to see whether there are problems where it doesn't ask you to calculate, but it asks you to think critically, right? Like how do you understand standard deviation from a meaning standpoint? You don't have to calculate, but understand what does it mean, right? Do you have a bigger spread or do you have a smaller spread? So standard deviation means how far you're from the middle. So look at if I think there's a way to calculate. You're going to realize that this is a lot. There are more people who are here in this spread than here. That means it's spread out. The numbers are more spread out, way more spread out. And you get that in school. Depending on the school you're at, you realize that wow, the numbers are so spread out. People who are doing really, really bad to people who are doing really, really well. Or you could say, wow, this grade level, everybody is doing about right here. They are all like right here. Right? It feels that there may be some errors or there may be some problems that everybody is getting wrong. And there may be some problems that everybody is getting right. Versus it's like, wow, we have some folks who did really, really great. And then we have some folks who like ace it. If there were a lot of people who ace it, then you kind of go, what is going on then? Right? So knowing the spread of data helps you make decisions. Not just like, we're going to put everything together and get a mean and then that tells it the whole story. It doesn't tell you the whole story. Does this make sense? I know maybe for some of you this is new. This is an area that, you know, it's an area in mathematics or statistics that you could have a PhD in because it's so much.
Area that I don't like.
I know.
I love it.
You do?
Well, in sales and
then
business
talk
and
about
corporate, you manipulate data to exactly tell your story. And you challenge people to question that data because if you've got hard facts, you can use and manipulate it. So I love this.
That's for me though.
That's okay. Everybody likes different things. But I want you to understand that This is a field that is very applicable to a lot of things, okay? Social scientists use this a lot. In order to communicate a story, in order to understand what is going on in our country, when you start having census data the next time, guess what? Census data talk a lot about this, okay?
But if you know how to ask the right questions when you read any data, it's really important.
Yeah. Because sometimes the graph in the newspaper is misleading, right? So learning how to read it, learning understand the spread, right? Understanding where the extremes are, understanding the middle number doesn't tell you how big the numbers are beside it, it's just the middle, right? Or that the most is just the most. It doesn't say, doesn't say the most in what, just the most, right? So when I put the number 15 in there, it doesn't make a difference, right? So knowing that it helps you as a consumer to make sure that you don't get cheated on things, right? Because when you say median income, that's just the middle number. What is the average income, right? Ask that question too, right? Okay. Yeah, if I'm gonna look, because I realize, and we'll have a practice test. As I say, I don't think they ask you to do the actual standard deviation, okay? But understanding spread, understanding median, how do you describe data? Basically what you're doing is that, what are ways to describe data? And normal distribution is a very common way to describe data, very common. Because ultimately, a lot of things can be explained in normal distribution. When you collect enough data, it will fall under some sort of curve. A lot of people in the middle, sort of, and a lot of people on both ends. In whatever you do, it's kind of the law of large numbers, right? Somehow things will fall into some sort of normal distribution. Okay. What does the word correlation mean? What does correlation mean? Related, right? Remember we talked about algebra and how algebra is about relationships? Correlation is kind of the more technical term, right? If you collect a lot of data, let's say I'm going to ask you, what is your GPA and how many hours you study? I'm going to ask you, what is your GPA, how many hours you study? Okay, I collect all that data, right? And then I'm going to plot them and say number of hours you study and what GPA you got. If after I plot it, there is a sense that the more hours you have, the higher GPA, that's a correlation, right? You're saying that there is some relationship with this data that I think there is possible relationship. Okay? So the more I do it, the better the correlation will look, because then I can say, wow, there is a pattern here. Okay? You can't just collect like 3 people, okay? You only collect a lot of people. Okay? So correlation that is positive means that it's trending up, right? That the idea is that the more hours you study, we hope that your GPA goes up. Okay, that's what we hope, for example. What might be something that trend down? What is something that may trend down? Let's look at GPA. What is something that negatively correlate to GPA? Huh?
Less studying.
Well, but that's just number of hours. What is another thing
Drug
that
use.
the more you do something, your GPA will go down?
Drug use or alcohol.
Huh?
The more you procrastinate, the
Because
more.
I just
could
heard
be,
a story
right,
about here and
right.
I hear the
Like the
exactly
longer
about
you
this exact
you go
story
and
about
study,
it.
right? Your test is say tomorrow, and instead of studying like 2 days ago, you studied 2 minutes ago. I'm making this up, right? I'm making this up. Or actually, how about TV? Number of hours of TV. I can tell that with the kid who's living with me, okay? Or playing games on the phone.
But you have to be careful between correlation and causation.
Absolutely. Thank you. Yeah. Thank you. Yeah. But from a sense of, now correlation doesn't say causation either. It just say that they are related.
Right.
Right? They are related.
But I guess it's overall data interpretation.
Right. Right. Because if you do a lot of this and you say, okay, the number of hours you play games and GPA, what do you think that correlation might be? What do you think the relationship will be? The more hours you play on game, what's going to happen to your GPA?
Nowhere to
Go down. So your trend is the other direction, right? The more games I play, the lower will be my GPA. Okay? Well, maybe not. Some of you may say not. All right? But you brought up a good point. Is it a causal relationship? Just because they are related, there is some relationship. Is it one causing the other? Sometimes you don't know. That is a whole field, again, in science. When they start collecting data, it could be in weather, it could be in scientific things that says, if you do this, you get cancer, or if you do this, you are more likely to have a disease. Sometimes they can tell you it's related, but they cannot directly tell you that it's causing each other, because there may be other things that are together, right? Let's say, like directly say a health issue. Sometimes it's diet and exercise and genetics and so and so, right?
Yeah.
Sleep, right? So sometimes the relationship is there, but it's not so simple, right? It's not so simple. And again, you won't be tested on this, but the idea of correlation is just what we've talked about.
But in a way, calculating for those variables is actually algebra, right?
Absolutely,
Yeah.
absolutely. It's just that when we think about algebra, what you've done the last time, the numbers are very clean. When you do this, you go up by 2. If you do the next one, you go up by 3. Right? You know that whole thing about the car? You know exactly how it's going to go up or go down, right? When you start talking about correlation, you have no idea what the relationship is. You are trying to figure it out. That's why I'm collecting data. I'm going to collect 100 people's data and then plot it
Oh.
and see whether there is some relationship.
So it sounds like this also will ask us how we're gonna interpret the graph.
Probably. Yeah.
Okay.
Yeah. You will not ask to have a formula to figure out what that
Right.
equation is.
And
No,
then
you
we
won't
just
be.
have to read a graph
Right,
and then
right.
figure it out.
You got to read a graph, maybe answer questions like, do you predict that if I do this, will this go up or down? That could be a question, right? That means you still understand, am I trending down or trending up? In general, right? You don't know the exact number, but you know that in general, it's going down, right? In general, right? So they might give you a bunch of numbers and you kind of go, oh, in general, I don't think it will go that way. It will go this way more. So that's logic,
Yeah.
right? You don't need to know the formula, it's
And
logic.
I just look at these two graphs on the page 9.
Page 9,
Uh-huh.
yeah?
And then there's income, years of education, and then you can just follow 19 years, and then you can know how much, and then at the last is $140,000 of income. And then do I combine 19 and 20 is make 39, but then why the
Oh, it
dots?
probably won't ask you to do that.
Stuff like that, okay.
No, it probably won't. It will probably be like, it'll say, what might be a possible income that you can predict for, maybe say 19 years, right? And it would probably not be $200,000. It would probably not be $20,000 either. So it might give you a list of numbers and think about which one makes the most logical sense. It's not exact, it might be just a range too. It might give you a range, right? It might give you a range. So logically, you're saying that if it is trending upward, but it might not go on forever, it might not go on forever, it might plateau, so the graph might eventually look like this. Because it doesn't make sense that like you keep going up, right? It might kind of go up and maybe it will slow down, right? So then the question is, if I have to predict based on this general trend, what is the range that might be possible, right? So if one of the possibility is, if you have 19 years of education, you probably make 10,000. Well, that is not gonna. That doesn't. The trend doesn't tell you that,
Okay,
right? The trend doesn't tell you that.
but it is going up. I mean,
Right. It is going up.
Okay,
Right.
so, well, instead of looking for the exact number,
Just logically,
Okay.
right? Logically, would that dot be really low or will be up a little bit higher,
Okay.
right? What is in general?
Okay.
Let's say you did 10 people, and if you did 10 more,
Mhm.
where do you think it will fall? So those are more logical questions than actual calculation.
Okay.
So understanding data and statistics, sometimes it's not about calculation, it's about interpretation, right? It's about interpretation, which is hard because you all want to tell, okay, what is the formula? I want to try a formula. I want to figure this out. Sometimes it has nothing to do with formula. Take a deep breath and kind of go, what is the question asking of me? Right? What is the question asking me? And can I logically think about this as if I'm in real life and somebody asking a question? Like, what makes sense? Okay. So it's going to require that you don't get all like flustered, because when your emotions are flustered, you cannot think logically as well. All right? So you being calm, which is hard because you have a lot of questions and you have very little time, that's why the more you practice, it's like, oh, I get it. Yeah, it's trending up. This is nope, yes, yeah. This might be only the two I have to figure out, right? So learning how to eliminate is also our practice, right? It's also our practice. How about probability? How many of you know probability? Huh?
I did actually did the lesson plan on that.
You did a lesson plan on it.
Yeah.
So I'm going to ask you this. Could you look at page 13? Okay? And there's a little blue thing that says, if it is or, you add. If it is and, you multiply. So I want you to read this first, and I'm going to give you another way of looking at this problem. So that when you forget, you're not going to get flustered. Okay? I want to,
Is the whole thing the same
yeah,
story?
so it's really,
We have to read the whole thing?
maybe, it's not very long.
Yeah, this is,
Yeah, you don't have to read the whole thing.
yeah, this is, a few of these are singlets. All it is rolling dice.
This is
Everybody
really
understands.
important to know though, because I
Probability.
remember the last time this came up, because it had to do with dice, and this is where it was culturally
Yes.
challenging to
Yes.
people.
Yeah.
And they had a lot of card stuff too in the questions in there.
Yeah. Unfortunately, they might still have those questions.
Yeah.
Right.
Yeah, unfortunately. Half of this is understanding the problem.
Yes, got it.
Half of it is understanding the problem, the words.
Yeah, this is the exactly.
They will ask, these are actually on test, in
Yeah.
some form of
Oh,
shape.
no, I'm fine with it.
Yeah.
I understand it. Like I said, I did a lesson plan on rolling dice and what's the probability on rolling
Wow.
two dice.
Wow,
I actually still have it.
really?
Yeah, that was last semester.
So how do you know when you add or multiply?
Add or multiply, ooh, that's a good question. 'Cause
Yeah.
that got me thinking. It's the total number of, so like, how can
So that's what I wanted to explain to see what
I,
it is.
yeah, okay, because that, yeah,
Yeah.
maybe I need to hear this.
Yeah, yeah, I mean, you might know how to do it,
Yeah,
right? You
yeah.
need to explain to kids too, right?
Yeah, that's
So that's the reason I always kind of offer another way of thinking about it.
fine.
So I know that culturally, sometimes this feels like gambling. Some of it is kind of just for some of you who
So or is add and is multiply.
it's game. Like there are games now that you might know this, where I actually went to one of this in the library, which is amazing. Kids were playing some sorcerer game, and
Oh,
they roll a die, not as a gambling thing, but rather it gives you a direction to where to go next.
mhm.
Because you are pretending, right? One means you are going into the dungeon. 2 means you're going up the door. 3 means that somebody is behind you attacking you. Right? So they roll the die to simulate an event. So if you want to think of it that way, then rolling a die doesn't always have to be about gambling. It's a way to simulate kind of what might happen next. Okay? And because otherwise it's hard for me to talk about this because I know culturally there are people, the dice means like gambling. So I want to think of it another way, right? So think of it as like a game. It's a
I
game.
mean, I understand where you're.
Yeah.
I don't think this is really culturally affects me, but point is, I've never played a game like this.
Yeah.
So I just understanding what, drawing a what?
Right,
What
yes.
are you doing?
I wish I brought a die right now. I
That
wish I had
one
a
is
die.
hard
Yeah.
for me to grab.
Yeah,
I
yeah.
have a game on my phone.
You have the game on your phone. Wow. So have everybody seen a die that is a cube that has 1, 2, 3, 4, 5, 6?
I've seen
Okay.
it.
Okay. Good. Good. All right. So does everybody understand that so the dice look like this, right? Right. 1 and then I don't even know what the order is. Like there's a 2 here, and then maybe there's a 3 here or something, right? Something like that.
Uh-huh.
So when I roll it, if I ask you, what is the chance that you'll get a 1?
1 out of 6.
One out of six.
One out of 6.
One dice, okay. I was
One dice, one dice,
Okay. I
one
was
dice.
doing 2 dice.
If it is 1 dice,
One out of
my chance is 1 out of 6, right? Because I could have 1 or 2 or 3 or 4 or 5 or 6. Okay? If I get a 3, it's still 1 out of 6. So 1 die is easy, right? 1 die is easy. It is when you either roll it twice or roll 2. That's where it gets hard. So what if I ask you, what is the chance of rolling a total of 3 on the die? On 2 dice. When you roll 2 dice, I'm going to get 3.
118.
I wanted 2 and 12.
118.
You say 118?
1 out of 36. Or 2
2
out
out
of
of
36.
12?
2 out of
2
36.
out of 12.
12.
Okay, let's see. Well, so I know you know it. I'm not going to say anything. Okay? I'm not saying whether it's right or wrong. So you think it's 2 out of 6? 12?
Wait a minute, could you please tell me what the thing is,
What's
what
the
the question
probability?
is?
So I have 2 dice.
2 dice.
Okay? And I want the probability of sum equals to,
So it's add,
yeah,
Yeah.
so then it would be multiply then, I think. So then you'd go 1/6.
1, 6
No,
plus 1.
You got 2 dice.
It is, oh my
I'm going
goodness.
You got
this is why we're talking about
You got 2
2,
dice.
3,
Yeah.
4,
And so you got 36 possibilities.
this. Where did that come from?
Yeah.
6 times 6.
6 times 6.
But why 6 times 6?
Because there's 6 sides to the die, and there's 2 die.
Isn't it?
This
Those
is
6
the
corners.
exact lesson I did. This right here,
It's even
the
hard
2
for
dice,
people
this
to
is the
follow.
exact
Okay,
lesson I
they're
just
making
did.
conversations, they're making
I know all the
conversations.
numbers.
So some of you know that you have to multiply. My
Why?
question is why?
Mhm.
And what if you forgot?